Hi, I'm Stacey Rohling, and this is my vision pathway from the retina to the primary visual cortex. Okay, my first high-tech slide is the iris and the pupil. This is what you see. This would be a right eye. Okay, the small black circle is the pupil, which is right here. It lets light into the eye. It gets smaller with more light and larger with darkness, and it acts like a shutter on the camera. The colored area is the iris. Okay, my next high-tech slide is, okay, we're going to start out with the cornea, which is right here. It looks like it's covering and protecting the iris. And then there's the screen right here. That would be the lens that is adjustable, again, similar to a camera. The ciliary muscle, which is right here, that controls the lens. The retina, which is this yellow portion around the eye, let's get that back up here, is that contains rods and cones. The rods respond to faint light, and the cones are more active in bright light and essential for color vision. The optic nerve, which is right here, that is ganglion cell axons that form the optic nerve. Let's get this back out here. Okay. Now the blind spot right here has no receptors. It's occupied by exiting axons and blood vessels. The fovea, which means pit, is the tiny area specialized for acute detailed vision. Incidentally, many bird species have two foveas per eye, one pointing ahead and one pointing down to the side. And a little bit more on that. Okay, I drew out a picture of the cells in the retina. Okay, the yellow are axons. The receptors send messages to the bipolar and horizontal cells. Where are they? Right here. Which in turn send messages to the amacrine and ganglion cells. The axons of the ganglion cells form the optic nerve, which is right here, which exits the eye at the blind spot and continues to the brain. And once the information exits the eye, this is the view of the brain from the top. So we got the anterior front portion up here with the eyes. Okay, and then we have the path that it goes. The optic nerve goes through the optic chiasm, then the optic tract to the lateral geniculate to the primary visual cortex, which is way in the back, which is the posterior of the brain in back of the occipital lobe. So what the brain sees, which is right here, nope, okay, it's right here, seen by the eyes, and if you were to just stop right there and not go any further, your brain would actually read somebody being upside down, similar to a camera. And then descend. Then you've got the brain that once it reaches the occipital lobe, it turns the image right side up. Thank you very much for looking. Have a great day.